Good day to all. Today our topic is system of units for physical quantity. Myself Dr. B. Suresh Kumar, Department of Mechanical Engineering. Every engineering student should aware about what is physical quantity, that how the physical quantity to be measured, how can we represent the units for that physical quantity. Here, the physical quantity, the base physical quantities are length, mass, and time, which can be measured with an instrument. These measurement of physical quantities are expressed in terms of units. So, the physical quantity can be classified it into two types. The first one is base quantity and the second one is derived quantity. For example, I consider the length of the physical quantities means the base quantity is length. Okay, here the length can be measured with the meters and which is known as base quantity. And how can I measure the derived quantity means if I consider the volume of cube means it has length, breadth and height. So length can be represented with the meter and breadth can be also represented with the meter and height also meter because all are consumed with the length. So length can be represented with the meter. Here I am placing three lengths, three physical quantity for measuring the volume, length into breadth into height. So that I got meter cube as the unit, which is known as derived quantity and derived unit. Then unit of measurement system. Here in our textbook we can see in front first page SI units. What is SI units? SI means International System of Units. The textbook always follows meter, kilogram, second, ampere, kelvin, mole, candela. Likewise, this full book follows the units. And some foreign authors may utilizing some other units like foot, pound, second. Here also FPS system available. Likewise, MKS system. MKS means meter, kilogram, second. And then CGS system is also available in textbooks and our engineering problems. CGS means centimeter, gram, second. Then what is meter in SI units? What is meter? Yeah, meter is the distance light travels in a vacuum in 1 divided by 2 crores 99 792 458 of a second, which is the meter. It may have 100 I mean 1000 mm, 100 centimeter, and also 1 centimeter is equivalent to 10 mm. Likewise, we can subdivide the overall units, but the meter is known as distance light travels in a vacuum in 1 divided by 2 crore 99 792 458 of a second. Here I have another question. How can I represent second? Yes, the second for a time. The second is the duration of 192 631 770 periods of the radiation corresponding to the transition between two hyperfine levels of the ground state of the cesium 133 atom. So that the atom radiation time between two pulses, which is known as the second. The engineering always follows the second unit. So that second, the per day it may be 24. The 24 hour is divided into 60 minutes. That 60 minutes is called as 1 hour. Every minute is may divided it into 1 second. So that 1 second is the duration of 9192 631 770 periods of the radiation of cesium 133 atom. And then what is kilogram? Next question, the base units, because the base unit always length, time and mass. And what is mass? Mass of a platinum iridium kilogram sample maintained by the Brou International Measures in Serres, France. So if I measure the mass means we can compare that physical quantity into standard one. So the standard is available in Paris. We can compare all other mass with that sample platinum iridium kilogram sample. So the determination of all other masses can be traced ultimately to a comparison with the standard mass available with the international mass standards in France. And then the ampere for electric current. So, the ampere is a measure of the amount of electric charge passing a point in an electric circuit per unit time. 6.241 into 10 power 18 electrons or 1 coulomb per second constitutes 1 ampere, which is known as 1 ampere. And then Kelvin. Every thermal engineering student follows Kelvin, and also doctor also measure the temperature of our body condition, so that we should aware about the basic physical quantity, which is Kelvin. The Kelvin is used to measure the temperature. So the Kelvin is the unit of the thermodynamic temperature scale. This scale starts at 0 Kelvin. The incremental size of the Kelvin is the same as that of the degree on the Celsius scale. So the Kelvin is the fraction 1 divided by 273.16 of the thermodynamic temperature of the triple point of water, exactly 0.01 degree Celsius or 32.018 degree Fahrenheit. According to this slide, you can understand the comparison between degree Celsius, degree Fahrenheit and Kelvin. The mole. Next, in our chemistry lab, we can select the substance, chemical substance, so that we can measure that it into molality level, so that we should also know about what is mole. The mole for the amount of a substance. The mole is a number that relates molecular or atomic mass to a constant number of particles. It is defined as the amount of substance that contains as many elementary entities as there are atoms in 0.012 kg of carbon 12, which is known as mole. Then candela for luminous intensity. In your physics laboratory, there is a spectrometer, so that you may measure the colors and wavelength of light. Based on that, you may have some experience. Yeah, there you may utilize the unit for as like candela Armstrong. Here, what is candela? Candela is defined as the luminous intensity in a given direction of a source that emits monochromatic radiation of frequency 540.1012540.1012 Hz, and that has a radiant intensity in the direction of 1 divided by 683 watts per steradian, which is known as candela. It is used to measure the luminous. Now you are aware about different physical quantity and how can we represent the unit for that quantity, and also in previous how our scientists represents the unit systems as like length, weight, time, and also other units. Now you are aware about. I think so. It will be useful for your engineering studies and other science studies. Thank you all.